Welcome to Lesson 3. Here we'll look at adaptive responses to overfeeding and underfeeding. Let's start off with metabolic adaptations to overfeeding. So anytime that you try to shift energy balance, whether it's towards a surplus or a deficit, the body is automatically going to attempt to mitigate this because, once again, the body likes the status quo. It wants to stay the same because underneath it all, it just wants to survive. So the body maintains its homeostatic drive in spite of your efforts to either gain weight or lose weight. So when overfeeding occurs, then the body experiences reduced appetite, and this can lead to a ceiling effect or a reduction eventually in food intake. Reduced appetite happens through increased satiety hormones, as well as increases in leptin, insulin, adiponectin, and also reductions in hunger hormones. Phenomenon called non-shivering thermogenesis, which is an increase in brown fat activity, also can occur. And this also contributes to increased energy expenditure in response to overfeeding. So increased energy excretion can occur. Increased non-exercise activity thermogenesis is one of the most interesting adaptations to overfeeding. And if you can think of non-exercise energy expenditure, or NEAT, as spontaneous physical activity, and think of things like fidgeting, think of things like subconsciously walking faster, moving more, sitting and lying around less. These spontaneous movements and spontaneous muscle contraction, even activity that happens through the sleeping cycle, can count towards increased non-exercise activity thermogenesis. And this increases in response to overfeeding. All right, so let's go with more metabolic adaptations to overfeeding. More details in this vein. Results from short-term studies are somewhat mixed when we're looking at the effect of overfeeding on resting energy expenditure. However, overfeeding studies that span beyond 30 days, then you pretty consistently see increases in resting energy expenditure to the tune of 5 to 12%. So this bullet point is highlighted because I want to make a distinction between what happens with overfeeding versus with underfeeding from a metabolic adaptation standpoint. So with overfeeding, the increases in resting energy expenditure are fully explained by increases in body weight and or fat-free mass. So with increases in body weight come a higher energetic cost of movement. And with increases in fat-free mass, you're getting just more metabolically active tissue. So these changes as a result of overfeeding fully explain the increases in resting energy expenditure from overeating. However, it's different with undereating. So with undereating, there is a phenomenon called adaptive thermoreduction, and this can be defined as a reduction in resting energy expenditure that goes beyond mere reductions in lean body mass. So we'll talk more about that. But first, let's discuss further the NEAT response to overfeeding. So despite that, the increases in resting energy expenditure are fully explained by increased body weight and or increases in fat-free mass, there's still substantial variation in this response between individuals. And this substantial inter-individual variation is largely due to individual differences in non-exercise activity thermogenesis. A perfect example is a subset of individuals that we colloquially call hard gainers. So these are folks who can try sometimes pretty desperately to gain weight, but they just seem to have a very tough time gaining weight. And oftentimes these individuals figure, gosh, I just have a fast metabolism, whatever that means. In reality, hard gainers, as we call them, are actually people who have a tendency to ramp up their non-exercise activity thermogenesis in response to a caloric surplus. So what we might call hard gainers, it might be more accurate to call them neat freaks or people who have a tendency to ramp up non-exercise activity energy expenditure in response to overfeeding. And I give the example of Levine and colleagues in their classic 1999 study, which was an 8-week trial using normal weight men who they fed 1,000 calories a day above and beyond their maintenance needs. The average increase in non-exercise activity thermogenesis was 336 calories. And so that's pretty substantial when you consider that if, for example, you wanted to be careful and give somebody a subtle caloric surplus for the purpose of gaining weight, let's imagine that you assign them a 10% caloric surplus, and that amounted to 200 calories above and beyond their typical maintenance. Well, if this person happens to be somebody who has a tendency to ramp up non-exercise activity thermogenesis, as in the case of what Levine and colleagues saw, then that 200 calorie surplus that you attempted to impose would pretty easily get swallowed up. All right, let's take a look at the neat response to underfeeding. And we can do that with the so-called calorie study. So this was a large study, a multi-center study, and it was a long-term study as well. It had a 6-month and a 12-month follow-up. And it began with a very severe caloric deficit until the subjects in the study lost 15% of their body weight, and then a maintenance phase kicked in. Now, interestingly, they did measure decreases in non-exercise activity thermogenesis. So at 6 months, NEAT decreased by 200 to 300 calories. And at the 12-month mark, non-exercise activity thermogenesis decreased by 190 to 330 calories. So in sum, we can at least speculate with a reasonable degree of plausibility that prolonged dieting can result in decreases in energy expenditure through the NEAT pathway to the tune of about 200 to 300 calories a day. All right, so let's talk more about metabolic adaptations to underfeeding. So unlike increases in resting energy expenditure from increased lean mass via overfeeding, decreases in resting energy expenditure via underfeeding are not fully explained by decreases in fat-free mass. And this, once again, is a phenomenon called adaptive thermoreduction. Okay, so going over the different metabolic adaptations to underfeeding that antagonize your efforts to impose and sustain a caloric deficit. Well, there's increased appetite. That's one that we've observed and most of us have experienced. So when you underfeed, appetite typically goes up. There's also decreases in satiety hormones and also decreases in leptin, insulin, adiponectin. And there's also increases in hunger hormone levels. There's decreased non-shivering thermogenesis. So in other words, reduced metabolic heat production from brown fat activity that gets reduced while dieting. Decreased sympathetic nervous system activity. So another pathway towards decreased energy expenditure, decreased levels of active thyroid, T3, decreased brown fat activity, resulting in a phenomenon called increased mitochondrial efficiency. So this is yet another metabolic adaptation that, in the case of underfeeding, results in a decreased energy expenditure. Decreased energy excretion can occur as well. And last but not least, there can be a decrease in non-exercise activity thermogenesis, which we just saw in the study we discussed. And this decrease in NEAT to the tune of 200 to 300 calories is typical in diets that are prolonged and or aggressive. And with that, we conclude the lesson, and I will see you back on lesson 4, where we discuss some more of the weeds, adaptive thermogenesis and adaptive thermoreduction. We'll see you then.